तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। We will continue with the real time clock Verilog coding, and I cross checked once again what I have written. Some people student expressed that some mistake was there, and please note the correction for the same. This is right at the input declaration. When you come to alarm 3, the comments are like this. It is only not in the code, but only in the comment that I had written there was a mistake. I will read out the comment. The correct version is this one. Only one of the 3 alarms can be read. I had put it as set earlier. That is what you mean, right? And set is not right. It can only be read. Although you can set all the alarms if you wish, but while reading you can only read one, because there is only one display available. And whatever if you happen to set all the 3 alarms, so naturally you can't read, and if you don't read any of them, then that's also not right. So what we gave is priority to these 3 alarms. So we called alarm 1 is the top priority, and then we are enabling that to be read. And if more than one is read, the highest priority alarm alone will be actually read, and others are ignored. This is the only change, and all other things are same. And you remember that we stopped at implementation of the stopwatch, and we will go to that point and then continue from where we left. And I think this is the one here. So we are looking into the counter 9, is that right? This is where we stopped, and here it is precisely the same. Counter 9 is for the stopwatch's most significant minutes digit. What we have covered so far, 7 and 8 for stopwatch, or hours display, and for minutes it is precisely same, except that the conditions are going to be different for each of these counters. For example, this is reset or advance only in the run and stopwatch mode of operation every 1 second. This is anyway precisely same for other modes as well, other counter modes. And when we want to reset the counter 9, so these are all the logic that we will have to solve, and as usual we will see only the comments, because there is no point in repeating what you already know. So only thing is you have only to cross check, because you can always you have this with you, that you can always cross check at any point of time if you happen to have CD. And counter 9 to 12 must be 5959. This is the condition for resetting this counter. We are talking of resetting the minutes counter, that is third counter from the left, 7, 8, and this is 9. Resetting, how to reset one conditions determine the resetting will be precisely as per this comment. And you can also advance the counter 9 for this particular status. For example, counter 9 can be 0 to 4 and counter 10 to 12 959. So this is the condition when you can advance by 1, and this is the pre-incrementing of the counter 9. And once again there is a decrement counter if you happen to be in the down mode, counting mode, for which the conditions are 1 to 5 for counter 9, and counter 10 to 12 must be all zeros. So we are down counting. So, if it is 1 to 5, then only we need to decrement the counter 9, which is precisely this. If it is 5, you will be decrementing it to 4, and note that other digits must be zeros, and pre-decrement once again, and this is the condition for presetting the counter 9, and the condition is 7 or 8 counter must not be equal to 0, and counter 9 through 12 must be zeros. So, this is clear. It should if all of them are 0, it has come to the terminal value. So, there is no further decrementing. So, only in order to take care of that only we are putting here, at least one of them must be not 0. And as usual, counter 9 implementation is here, the reset condition, then advance, then decrement condition. When this condition take place, only then it will do either the advancing or decrementing and or presetting. In this case, this is minutes, so you can go right up to 5, and this is the preset value. After 0, it should roll back to 5, and that is why preset count, when it is 1, it has been made to 5, preset to 5. And next one is counter 10, the stopwatches least significant minutes, and this advanced or reset only in run and stopwatch mode every 1 second. This again once again the same thing, and counter 10 to 12 must be 9:59 for condition for reset, and for condition for advancing the counter 10 is 0 to 8, and counter 11 12 must be 5 9, and once again pre-increment is there and pre-decrement is there, and decrement once again applies only for the run stopwatch down count mode, and condition is for 10 equal to 1 to 9, and 11 and 12 must be 0, this decrement counter, and pre-decrement again, and the condition for presetting the counter is here. It is counter 10 to 9 must be preset to 9, and only if counter 7 through 9 is not equal to 000. So, once again this is clear, I hope, and also counter 10 to 12 must be zeros. So, all of them 0 except for this condition. This is for presetting the counter. Then the counter 10 realization is here, as usual, reset, then advance, decrement, then preset, and preset in this case is when it is 9. What we are doing is for 10. So, that is 5 9 is the maximum thing, and 9 corresponds to the counter 10. This we are concerned with only minutes LSD, and 11 is for stopwatches most significant second digit, and other conditions are same, and the condition for resetting is once again 11 and 12. Now, we can see progressively it is getting easier logic, and it is 5 9 for as far as 11 and 12 counters are concerned. Same is the case for advanced counter, except for slight difference, that is counter 11 must be 0 to 4 and counter 12 must be 9. This is the precondition for the same, and advance increment is here, then decrement counter 11, this is the condition for decrementing, and as usual that RSG signal has been used here, and counter 11 is from 1 to 5. This is for seconds MSD. So, maximum that you can go is 5 here, and this is for the condition for decrement. If it is 1, 1 can go to 0, but if it is 0, it can't go down further. So, you can decrement only with the relevant digits. That is what the implication that we have been looking into all along. And once again the pre-decrement, then presetting the counter 11, and you preset only if counter to 5, only if counter 7 and 10 not equal to all zeros, and of course 11 and 12 must be 0 for same condition which we have been seeing. And again reset, advance, decrement counter and preset counter 11 of course, and 11 the maximum number is 5. So, we roll back to 5 after prior to this it was 0 at the decrement mode. So, now the last digit, seconds digit LSD is here, and once again the reset condition is counter 12 must be 9 is the condition for resetting this counter. Counter 12 is itself, and advancing the counter is for counter 12 equal to 0 to 8. So, this is for advance. If it is 0, it can become 1, if it is 8, it can become 9. Therefore, the valid number is 0 to 8, and advance pre increment, then decrement in the down count mode, and in which case counter 12 is decremented every second only if counter 12 is 1 to 9. So, 1 can become 0, 9 can become 1, and so on. And once again pre decrement and preset the counter, and this happens only if counter 12 7 to 11 is not equal, or not equal to all zeros. Counter 12 also must be equal to 0, and it is preset to 9 in this case. So, this block for counter 12 is this, precisely the preset is that 9 will be reflected here, that is here, and all the other things are similar. Then next what we had to see is, we had to see the terminal count register for up counter. So, in up counter mode, what we had to look for is, you are going to set a particular value, and it counts right from 0, 1, 2, 3 and so on. When the terminal count, that is what you have set, is reached, a match is found. So, that is what we mean by terminal count here. For up counter it is one thing, for down counter it is another, and for that you need this signal also, which implies reset terminal count register 1, and this must take place only with advancing hours, and TCR is precisely terminal count register, right. Only when this happens and terminal count reg 1 is equal to 2 and terminal count reg 2 is equal to 3. So, this remember this register 1, 2, register 1 through 6 are there. So, this is for up count, is not it. So, terminal count we are looking for when it is equal to 2, 3. So, only then you need to energize this signal for it is a reset terminal count reg 1. And next is advanced same reg 1 you need to advance also, and for that exactly the same condition there, and this terminal count reg will be less than 2 and equal to 9, and this is that means 0, 9 or 1, 9 is implied there, and it is similar to your counter 1 or counter 7 that we have already seen before. And once again you need a pre increment here, and this terminal count reg 1 is realized as we have done before, and you need to reset or advance it, and there is no decrement as such here. Similarly, for reset term count reg 2, you say precisely same as what we have seen for reg 1, and that is I think I have not even put the comment here, and advance counter is also here, and you can very easily reason out what they are. Less than 2 means 0 or 1, less than 9 means 8. So, you can easily find out what they are, and terminal count equal to 2, or here it is less than 3. Only for that you need to advance. Mind you, we are just trying to advance the second register, which corresponds to hours LSD, and pre incrementing is there in that as usual for counter 2, and once again the register advance is there. We assign the next value here when the clock strikes. Next is reg 3, and once again reset term count, advance term count, then pre incrementing are all precisely the same except for the conditions shown here, which you can easily reason out here, except that some difference is there. Earlier I think it was hours, now minutes will have to be taken into account, right. And this condition also I think we have already covered, this minutes TCR earlier, and once again the realization of that particular register, say term count reg 3 and incrementing happening here, and similarly for reg 4 there, and with all that reset advance and pre increment, and then the actual register implementation. These are all precisely same, I do not have to again repeat the same thing which you are already familiar by now. Reset advance once again pre increment for the counter 5, and this is for seconds MSD, and this is the realization for the same, and the last one in this sequence is reg 6,
and that will happen for seconds. So, that is why this has been taken into account. These signals are already shown earlier. It means advance in seconds and terminal count rich all being matching, and realization once again pre-increment realization of the counter is here, and this precisely all the 6 are almost identical except for the signal change, and timer out is set when the terminal count up or down is reached. So, you remember that we have a timer out, for example, to fire a rocket we have already seen. So, when you can do it in 2 ways, either up mode or down mode. So, when the set value is reached, then this timer out goes high and remains high there. Concurrent to this sound alarm is also energized, but that will be on only for 30 seconds, a beeping alarm you will get on that. But as far as timer out is concerned, once it is the time is over, it goes high and remains high, and it is unlike that beeping output. And if you want, this is also a counter basically, and pre-increment is done in the same fashion. And why we need this counter is we need to keep track of the alarm, audio alarm, and we have already set it for some say 30 seconds. If you want 30 seconds, you can change that also. In fact, you can change from this statement you can see here, right. And if you say timer out alarm, this is nothing other than timer out have we declared earlier. Sorry, this is the output, right. So, when the timer out is 1 and timer out alarm counter, which is what we are going to see, this is the next, which is exactly the same, this counter we are going to see below, and when that counter is not equal to 31, so only then, and if this is 1, only then timer out alarm must be on. That means to say this must be on only for 30 seconds, not beyond. Is it right? This signal is high for 30 seconds after terminal count is reached, that is timer out equal to 1. So, this is the condition. So, timer out counter is precisely like any other counter except for little changes. We have an else if here, if timer out equal to 0, that means it is not yet energized. So, what you need to do is the counter is also cleared, and if timer out is 1, that means 30 seconds have lapsed. Not so it is not lapsed. Okay, timer out is high, right. This can be high only when the terminal count is reached, isn't it? So, that terminal count is different, this counter is different. This counter is only for sounding the alarm. We need to sound the alarm just for 30 seconds, otherwise you get annoyed with the buzzing sound all the time, right. So, whereas timer out is the one when the set time matches with the when the running time or stopwatch for the right, only for stopwatch matches with the set value in the count mode, be it up or down, then only timer out is set, only after the lapse. After it is set, then only this 30 seconds will come into play. That is why timer out not equal to 31. So, 30 means it has already sounded, when it is equal, it has already finished the sounding for 30 seconds. That is what it means. Then this will go low, and this won't be satisfied, right. So, we need to satisfy this so that we may sound the alarm only for 30 seconds. That is the implication of this, and this should happen only every second, right. Otherwise, you increment the actual alarm counter. And we have another set of always blocks for various purposes. For example, you remember that we have a push button switch for start and stop, right. And why is this register necessary? Because we have only one push button switch, and when we push for the first time, we should take the system into start mode. If you push the same push button again, it should be turned into stop mode. Start and stop is applicable only for up counter and down counter, right. So, whenever you want to start the counter, what all you have to do is press the button and it will start, and when you want to stop, press the same button again. So, you can use for dark room, you can develop your films, etc., using this precisely same real time clock in the down count mode. Even up counter you can use, and there is going to be a buzzer after the set time is lapsed, and it will freeze at the last value.
If it is down count, it will be all zeros and stay there, and the buzzer will sound for 30 seconds and be silent thereafter, but the output itself will remain high. And then what we need is the same signal, we also need to know the previous value, so that we can sense when the start stop was pushed, right. So, this will be known only if you register at every clock pulse or every time this logic is satisfied. Here this is only clearing the logic when power on system reset is encountered, and this is the previous value of this, right. And if set stopwatch is 1, that is literal meaning you should take here. When you are in setting mode of stopwatch, then what you should do is you have to stop the running count up down counter, right, because we do not have to do any action at that point of time. And on the other hand, if your start stop is 1, which implies that you wanted to start and it is already in start mode after you push for the first time, and then the previous value we have already just now seen, that must be 0. 0 1 senses the rising edge of the push button, that means the push button has been pressed, okay. And run stopwatch must be in this run stopwatch mode, no n, note that, and this is plain straight, and stop n is the debone start stop push button input. It is a comment for this, and look for rising edge depression of the push button switch, that is the comment what we have just now explained. And here what we should do is whenever we push the button, so it has to toggle, right, because we have only one register called start stop n. The same will indicate whether it is in start mode or stop mode. First time you when your system initializes resetting, this will be cleared, and subsequently when you push the start button once, this will be made 1, and subsequent pushing will have to be inverted. So what you need is an inversion, and that is precisely this statement is for. The same signal is inverted and assigned to itself. In other words, it is toggling between start and stop. This is how you achieve with single button rather than having to use 2 different buttons. And another thing is this previous value, you should not forget to load it with the present value, and this is an important thing. If you miss this one, it will not work, okay. And preserve as the previous start stop value, and this one is also precisely same. If none of these conditions are met, then also you should not forget to preserve the present value into the past value. So next is we need to generate 2 seconds. One of your questions was should I hold, how long should I hold? We need to hold it for 2 seconds, and that is precisely what we are going to implement now using this hours 2 second and reg, and this is the pre increment for that. And once again, being a counter, we have to have it in a positive edge clock always block, and this is the usual resetting, and we need to have this is the actual register here. We also need a delay output, so as to keep track of that pushing continuously for 2 seconds. So this is what is going to keep track of that, and also this is basically derived from hours push button, right. If you push the hours button for in order to set, only all this come into play, and the condition for hours is the debones condition of push button hours is hours, and its previous value is what we earmark as hours p, okay. And these are all to be initialized to start with, and if hours push button is released, right, what will happen is hours is going to become 0, right. If you push also, I think it should go to 0, right. Is this comment just examine yourselves. Clear on delay output. So these are all the precondition, right. If hours in a release condition, this is the one. If it is pushed, I think it is 1. Let us clarify that, okay. So that is why we are trying to initialize this. So this is 0, mind you, and previous value is the actual hours. This current value is taken here and assigned as a previous value. Hours is the hours push button input. Clear 2 second counter. This is a 2 second counter as I mentioned, and it needs to be clear, right. That means push button is not pressed for incrementing that display, right. And now next is if hours 2 second, suppose it starts running, we have not spoken of running yet. If it starts running and we look for 20 value, right, this will give exactly this time base is 0.1 second once again here, and after 2 second 20 would mean 2 second delay or greater. This is how you reckon the actual delay. So this is the running counter for keeping track. So it will start from 0, 1, 2, 3, it will start advancing from 0, 1 and so on, only if you had you press for at least 2 seconds, only then this will come into play. So here when this happens, that is after 2 seconds delay, this hours delay goes high. That is what I was saying. When you start the thing, hours output delay will be still continue to be 0, and only after the lapse of 2 seconds delay it will go to 1. That is what is happening here, and you should not forget the current hours push button to from being preserved, right. You have to preserve that. Note hours to as register is not reset here. So I am just inviting your attention by saying that it is not reset here, it is reset when hours push button is released as above. Earlier we have seen release here, right, and here, right, here only it is reset but not here. This is after the time is lapsed, just after the 2 second delay, then only you need to do this, okay. And next condition is counter decisecond, we want 0.1 second. So when that is equal to the set value we have defined earlier, this one, and also hours push button is 1, okay. So only if this condition is satisfied we need to increment the counter, right. That means we are incrementing every 0.1 second, okay. So 20 is what we have put earlier, just now we have seen 20 into 0.1 will be 2 seconds. So that is how you get that, okay. Is it clear or some problem is there? Now let us see, advance the count once every 0.1 second so long as hours push button switch is pressed, otherwise ignore. Did I convey the same thing or I made a mistake? Is it okay? So 0.1 is the time base, so 20 you are trying to count. Each time what we have seen is merely incrementing when that condition, when condition is 0.1 second. Whenever a 0.1 second condition occurs, you merely increment this counter, and when it is equal to 20, stop that. We have forced it to 0, remember that this, and here also clear on delay output, preserve as the previous value. This also you have to do, okay. So is this speaking sense, okay. So then if none of these conditions meet, you have to just preserve once again, and so is the case for what we have seen so far is for hours. Similarly we need for minutes, okay, and as well as seconds. So I am not going into very much details, I will just leave it to you. You can just go through that. All this very same thing we have got here. If minutes instead of hours is encountered, what action you have to do, precisely the same thing, right, all here. And again if it is 20, which means 2 seconds, and what we need to do is, so now what we are earlier what we spoke was for hours, only 2 digits hours display will be managed there. Now we are going to manage next 2 digits for the minutes alone. So that is what we are doing, and next 2 digits will be for seconds, which is going to come over here, and this is precisely the same condition in decisecond meeting, and this time it is minutes push button switch. So based on minutes push button switch only we need to take the action, and these are all precisely same, and so is the case for seconds here, and advance increment, then reset condition, all this, and once again instead of hours or minutes equal to 0 we do this, and relevant registers we set or reset, and once again we sense 20 here, and the delay is again made 1 and previous value set here. So once again if this condition is met, only then we increment. As usual it is precisely the same. So and otherwise preserve the value. So now what is left is alarm implementation. It starts right over here. For this we need temporary alarm reg 1 to 6 or a set of 4-bit temporary registers which hold the alarm time when it is being set.
So, then assign we assign this particular signal, which means advanced temporary alarm register 1, right. We do only when advanced hours temp alarm is 1 and temporary alarm reg is less than 2, that means 0 or 1, and this must be next must be 9, which means either 0 9 or 1 9, only then you advance what it is the alarm setting we are talking of now. So, again once again reg 1 will correspond to what, so hours MSD, right. So, that we are talking about here, and similarly reset condition is here, and for 2 3, and this is same condition, and pre-incrementing the register, and once again as usual we have reset condition for the realizing the register 1 temporary alarm. What we do is we first have a temporary alarm for all these 6 registers, right, all corresponding to the 6 counters that we had or 6 displays we had, and pre-incrementing is assigned actually here, and similarly for reg 2 precisely it is same. I am going to read only the comment. So, here you are going to advance this alarm setting only if it is 0 0 to 1 8 other than 0 9 and 20 to 28, only then you need to advance, right, not otherwise. Similarly, you can reset only when it is 0 9 or 1 9 or 2 3. This is as far as the second register is concerned, which is corresponding to 9 or this 9 or 3, because this is the terminal count. After that it has to become, say it is it will, whether it is up counter or down counter setting or alarm counter, all will go only in the forward direction, incrementing only. And once again pre-increment for that, and the temperature 2, I mean sorry, temporary alarm reg 2 is precisely same as previous thing, and once again for 3 you have advance as well as reset here, and this the condition is 5 9 here, and then once again pre-increment and the block for temporary alarm reg here, and this precisely exactly same. So, is the case for advanced reg 4, right, and condition is 0 to 8 in this, and reset for 9 as far as 4 is concerned. Once again there is a pre-increment and block for realizing the same, this is exactly same, and only thing it will advance for 0 9 or 1 9 or 2 9 3 9 4 9, right. This is I think it is clear. It's, we are in 5 and one more is there, this is for seconds, right, and assign this is also required for resetting for 5 9, and again pre-increment and the block for 5 is here, this is once again same, and the last digit for seconds LSD here, advance reset, then pre-increment all are there, advance for 0 to 8 or reset for 9, and this is the block for the alarm reg 6 here, and you assign here, and as usual all the other reset etc. And here next is we need to set alarm 1. If you want to set alarm 1, what we should do is we should set stopwatch and alarm read set in set mode with alarm 1 set, right. So, set alarm we have already seen, alarm 1 must be in one position, this is the debound switch position, that's what we are calling as set alarm 1. So, what we should do for this is, once again the block is there, for alarm 1 you will have alarm 3 alarms are there. So, corresponding to that there are actually once again 6 displays corresponding to the same order. So, this being the hours and so on, and like this we have this is for resetting, we need separate registers for setting the independent alarms, we can't have the same temporary alarm, and temporary alarm is first set and then transferred here, that is what we are going to see later on. If set alarm 1 we have seen the condition, if it is set, what we should do is we have to set the temporary alarm, from temporary alarm we are setting to the independent alarm, here this is what we are doing, copy alarm setting from common set register into the particular alarm register, and precisely the same here down for up to 6 registers, and set alarm 2 is similar to set alarm 1, and the condition is clear except that alarm 2 is now 1, and the block for realizing the same, once again reset power on reset here for alarm 2,
and here temporary alarm is set to this provided set alarm 2 is there. So, same is the case for alarm 3, that what we have precisely the same thing. Here we are setting from the temporary, and now so suppose when this is a block, I have lost track of this, let us have a look at this. So, when alarm 1 or any of the alarms, then we need to take some action. So, what is that one we had to do is, so we had to read the switch positions for alarm. There are 3 switches, am I right in this? Please correct me if I am wrong. This is the power on reset, read alarm reg, that is a reg for this, for keeping track of read alarm, is it? I will just read the comment. Read alarm reg is a 2-bit reg which stores the number of the alarm to be read. So, there are 3 alarms. So, you need to keep track of which alarm we are speaking of reading, right. Reading means displaying, and so each of this alarm has been assigned some unique number. For example, if it is 0, so you need 2 bits to represent 3 alarms, right. So, here which stores the number of the alarm to be read. If no alarm is on, it stores 0. So, 0 corresponds to no alarm being set, and if alarm 1 is 1, that is the first alarm is set, this is a physical switch, and after debouncing, if more than one alarm is on, the one displayed red is the top priority alarm. So, alarm 1 is the top most priority. I hope there is no problem in this, right. So, earlier we corrected, you remember, and so here we need to set this register read alarm reg to 1 for that condition. If alarm 2 is there, that was for first alarm. If alarm 2 is set, on the other hand, this reg will be forced to 2 value. If alarm 3 is encountered, on the other hand, this will be set, right. And note that this is a priority encoder. So, so this gives the topmost priority to alarm 1, because that was the very first statement. That is how the priority is assigned. This is clear to you, and if none of this is met, simply make it 0, which implies that no switch has been set for that. So, next one block is display real time or stopwatch or alarm on the 7 segment LEDs, right. So, we have this data 1 through data 6 we saw in the simplified architecture earlier, just for the display, and we need to clear first, and then if you are in display time mode, which implies that we need to display the actual running time. If you are in that mode, what all we have to do is take counter 1 through 6, which is the running counter, and assign it to data 1 through data 6. Otherwise, if display stopwatch mode is set now, what you have to do, and once again you have to set this condition also, I mean check this condition. If it is in set stopwatch mode and also in down or up, it is in up mode. If it is in set stopwatch for up counter, then what you need to do is, we have to take that terminal count reg 1 and then assign it and push it to the display. Data 1 through 6 is nothing other than the display, and otherwise what we have to do is, this is for stopwatch. Otherwise, we counter 7 through 12 is earmarked for the stopwatch. We need to display, push it to data 1, which in turn will be displayed, and if set alarm is 1, indicates that alarm is set, and therefore temporary alarm reg 1 through 6 will be displayed. So, this is what you want, because you want to alarm is set, and therefore you want to display the set alarm, right. Otherwise, this is what condition, this for set alarm, okay. So, only here we do the same thing, temporary alarm is pushed to the display, and there is one more mode, one or many in fact inside this. If it is in display alarm mode, so we have a few more classes here, and first this is alarm set is displayed, and in this case it would depend upon read alarm register. So, we have, you remember that we have given corresponding to which alarm is set, we have given some number for that 0 through 3, and that is what is here, and if it is 0, you do not have to do anything, hopefully it may come at the end, I think. If it is 1, it means alarm 1, right. So, we need to display the alarm 1. So, what all you have to do is alarm 1 reg 1 through 6, which we have already set earlier, we will have to push it onto the display. Otherwise, if it is 2, it means alarm 2, then you do the same thing, but this time you do from alarm 2 register and push it to the display. Otherwise, it may mean alarm 3, once again you do from the alarm 3 display register onto the display, and that ends that particular set alarm, and we are yet to go some more distance before we complete. And here what we need to do is alarm 1 match, and for this these are all the conditions. When alarm 1 equal to counter 1 and alarm 1 reg 2, this is the hours and the minutes then seconds. When each of them equals the running counter, this is a run time basically, then what you should do, this alarm has found its match, isn't it? You have set one alarm time and a running counter, when it matches that set value, this is precisely the statement which is responsible for turning on the alarm, right. Set if present time equal to alarm 1 set time, and you notice that we also needed a 30 seconds buzzer activity. So, what we do is alarm 1 30-second delay is a bit which becomes 1 when alarm 1 match equal to 1. It stays high for 30 seconds and then goes low. Alarm 1 30-second is a counter which counts till 30. It counts so long as alarm 1 delay is high. It is incremented every 1 second when time base equal to 1, right. So, we need for this an counter, and for this alarm 1 30-second counter, advance is the signal that we need to get. This is for 1 second, and this one is when alarm 1 30-second lapse of delay, is it, and this is the advance count for that. And once again the block which initializes these two, delay as well as the counter, and when alarm 1 matches, only then we set the alarm 30-second delay 1 here, and when counter is different, delay is different. This is single bit, whereas the counter is multi-bit here, it is a 5 bit. When it matches with 30 seconds, then turn it off when the delay is complete. Delay is complete, that means. So, then turn it off, and then also you should not forget reset the counter, that is what we are doing here. And if alarm 1 30-second counter is 1, now you have to only increment. So, we are counting that 1 second, right, using that 30 every time TB second we have used. So, that is how you are counting for 30 second. Similarly, for alarm 2, alarm 3, delays and counters work similar to that of, this is precisely same, counter 1 to alarm 2 this time, and this is for match, and this is for advance, precisely same, except that alarm 2 has come into picture, pre-increment, then block for realizing same thing, and again match for alarm 2, then all this when this match is 30 seconds it does that, then advance the counter and assign the pre-incremental value here, and alarm 3 match when it is equal to the running value, then match is found, and then energize the signal. And what you then you also need advance alarm 30-second corresponding to alarm 30, which we have already seen earlier for 2 and 1, and pre-increment that counter, once again realize the same counter, and there are two parameters once again. When the alarm matches, what you do is just reset, set that particular thing to 1, right, the delay. So, the delay is the one which keeps track of the 30 seconds whether it is over or not, and here it implies when this is equal to 30, it means 30 seconds complete, then you have to just reset the counter ready for the next event. Then you advance the counter when it is this signal is 1, right, and assign the next. So, now what is left is we need a ring signal, is a signal, intermediate signal. We actually need a beeping signal. Beep is the signal, it is a square wave that we want to create, which is actually output to the speaker if ring is high. Ring is an intermediate thing, is a signal that indicates that one or more alarms are active, right. And beep counter counts, we have a counter also till 2 means 0.2 seconds. When it is 2, beep is toggled producing 2.5 hertz beeping tone. This is how you get a beeping tone. When you see the demo, you will clear it, clearly hear that, and because we have not put a mic right now, you couldn't hear that. beeping tone if alarm off on switch is on, right. So, only if the alarm, there was another switch for that off on, only if it is on, then only you can hear it. That does not mean activity is not going on, it does go, but you can hear only if it is in on mode, otherwise the sound alarm is off. Then assign ring is the signal. So, when alarm 1 30-second delay, either that one or second or third delay plus this timer out alarm which we have already seen is 1, then only ring will be energized. Timer out alarm signal is high for 30 seconds to sound the audio alarm after the terminal count up or down is reached, that is timer out equal to 1. So, assign beep counter next, this is the pre-increment, and the block for realizing the same is here beep counter we are doing, as well as having the beep output here. So, we initialize this one, if ring is 0, ring 0 means no alarm is active, and once again you do the same thing as this one. If beep counter equal to 2, and now what you have to do is beep must be inverted and fed back only in alarm off on, that means it is in alarm is on condition, only then you need to beep, right, either this condition or timer out alarm is also 1. So, either of the two conditions having met, what you do is you assign it to beep, right. When this condition is met, it will assign beep equal to 1, right, it will set beep. Toggle if alarm switch is on in on position, or if timer out alarm is high, right, that is what it means. Then you can reset counter 0, and otherwise if ring equal to 1 and this is decisecond once again, then only do the incrementing here, right. So, next we are going to complete the design, call the BCD to 7 segment display conversion ROM. We had to, this is the display ROM, and we need to call that here by using this, and this is instantiation of the same, and it is nothing but a ROM table. There is an address input which can be given as from data 1, data 2 and so on, so that we can straight away, this will do the code conversion from BCD to 7 segment display, and that output can, which is say display 1, you can output. If you want to independently control the decimal point, you can put 1 here. So, precisely like this display 1 through display 6 we have here, precisely each time data 1, data 2 different data are sent here, and that is the reason why we get a display, and that ends the design. And sub module we have used for display ROM is here, display ROM is the sub module for conversion here, it is a ROM table. Logic 1 is meant for turning on the segment, it is a common anode mode you can have. So, this is the declaration of the module, and address decimal point out or the IOs here, and we need to declare all the inputs, 4 zeros displays 0, if you put 1001 it displays 9 and so on, right. All other things are illegal value as far as the display is concerned. If you want decimal input, you have 1 here, and output you need 8 bits, 7 segments A, B, C, D, E, F, G, and decimal point, this is the order, A is the MSB of this, and DP is the decimal point is the LSB. A is the top segment, B is the next segment clockwise, and G is the center segment. You need to declare out as reg, and this is the case statement using this only a combination logic, you can just see it. Case depends upon the address. This address is what you give as the input, which needs to be converted from BCD to 7 segment, and this can go right from 0 through 9. For each the output will be different, and that is assigned here. For example, all ones except for the last one. 0 means this is A segment is first one, B, C and so on, and this is G, that is center segment, and decimal point here, if you put 1 it will turn on, and that is what is meant here. All 1, 2, 3, 7 up to 9 is precisely the same, except that the values change here. So, for example, you can just analyze and convince yourself that it is working, and let us take one example. For example, this is 9. What you should have is it will go like this, and all segments are there except for this segment, right. So, what is this segment? So, this will be last center will be G, this will be F, and this will be E. So, E segment must be 0, 0 turns off. So, is it E, A, B, C, D, E, precisely. So, you can analyze like this and convince yourself that it really works. Default is we just put 0 which will blank the display. For any other other than 0 through 9 it will blank the display, right. Any illegal data you give, it will blank the display. This ends the design, and we have a test bench for this real time clock. This is a test bench. Shall we if you want, you can have a question here, and so that we can wind up, we will take up the test bench a little later. You have any specific question, you can ask me. So, what is left out is the test bench. So, going to be only a small thing, and followed by the waveforms for this, and this test bench is not going to be very elaborate, it is going to be very short, and because we have already seen how we have entered the maze and come out of it, right, all intertwined counters. So, we can't naturally write a very elaborate test bench, and if you have any specific question, we can answer. Do you have any?
Sir, why exactly do we do this debouncing, sir?
Debouncing of the switch.
Why do we have to do it?
See, if we do not debounce, multiple inputs will be given, right. So, it may not be all that necessary for everything. See, for example, you want to push a button, what do you expect out of it? If I push once, you should increment only once, not 100 times. Erratically it will behave. If you do not debounce, it will give multiple pulse, because you are counting the pulse applied, it will be erratic. You expect just one increment, 1 must go to 2, but you will be annoyed to see 1 going to 8, 10 like that. So, that is the purpose of debouncing. Is it answered the question? You have any more question? Thank you.